This lesson is 1.4 Radicals and Rational Exponents. Okay, so to do this lesson correctly and with ease, we need to first talk about perfect squares and perfect cubes. Alright, so remember, perfect squares would be like if I take 2 and I square it and I get 4. So this would be considered a perfect square. And a perfect cube, take 2 again, we cube it, we get 8. The 8 is considered a perfect cube. Okay, so what I'm going to do is I'm going to list these first perfect squares and perfect cubes. So 1 squared is 1, 2 squared is 4, 3 is 9, 4 is 16, 5 is 25, 36 for 6, 7 is 49, 8 is 64, 9 is 81, 10 is 100, 11 is 121, 12 is 144, 13 is 169, 13 and 14 are similar. All I do is flip the 6 and the 9. I get 196 for 14, and then 225 for 15. Alright, those are the ones that you should be expected to commit to your memory banks, but you have calculators just in case you need them. Then we have cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 is 64, 5 is 125, 6 is 216, 7 is 343, and then I'm just gonna stop right about there. Alright, because the cubes grow really fast. So why are we doing perfect squares and perfect cubes? Because first we're going to simplify radicals. So we have square roots, okay, right there, square roots, and then we have cube roots, which is right there. Okay, so from here, to simplify a radical means to break it down in its most simple form. So we have to see if there's any perfect squares that go into 252. So you can start high and work your way lower. Alright, so we got 252. So numbers that could probably go into that would be 144. Check, I got my calculator here. 152 divided by 144 does not work. 121. So I'm working on the high end and then working my way down. 121 does not. 100 doesn't, just from looking at it. Maybe 81. No. 81 doesn't. 64 doesn't. 49. And let's try 36. Perfect. 36 times 7 makes 252. So break it up, make them both square roots. Now I'm just going to take the square root of 36, which gives me 6. And since 7 is not a perfect square, I just leave it alone in the house. And I can't simplify any further. So 6 square root of 7 is the simplified form of square root of 252. And we'll just do the same thing for B. Alright, looking at B, the nice thing is that 121 is a perfect square root. So I'm going to pull that out. Got 121. You got x to the 5th. Alright, so with exponents, they need to be divisible by the radicand. And our radicand here is 2. It's always 2, we just don't write it all the time. So I just need to, since it's an odd number, I just need to take 1x out. Alright, so I take one exponent out of the 5, I'm left with x to the 4. And now 4 is divisible by 2. Then we look at y to the 6th. 6 is divisible by 2, so I'm going to leave that in the house. So from here, I'm going to simplify. Square root of 121 is 11. X can't take square root of that, so that stays square root of x. Square root of x to the 4, so I take 4 and I divide it by 2. So I get x squared. Oh, I worked ahead in my brain. So it'll be y to the 6th right there. And then, so I take 6 divided by 2, and it becomes y cubed. Now I just need to tighten this up. So I have 11 x squared y cubed square root of x. All done. Now cube roots are a little trickier. Alright, so what I'm going to do with this cube root, so I'll take that -1 out, and I get 162. And I look at the 6, that's divisible by 3. So I'm going to leave it as m6, and then the 9 is divisible by 3. So I get this. So I get cubed root of 1. No, hold on. I don't want to do that yet. Okay. So negative 1. That's it. We got to break down the 162. All right. Perfect cubes that go into 162. So perfect cubes. All right. Let's start. We got 216, which is too high. 125 won't go into 162. So I'm just using this list up here. Oh, here we go. So that won't work. It's too high. That won't work. So I'm going to try and plug in 64. So 162 divided by 64 gives me a decimal, so that doesn't work. So I'll do 62 divided by 27. That's going to give me 6. So this would be 27 and 6. So their cube root can't break 6 down any further. So that cube root of 1, cube root of 27, cube root of 6. And I pull out the negative because I want to work with positive numbers, not negative numbers. We got cube root of that times cube root of that. So moving down, cube root of negative 1. So if you just take negative 1 into the calculator, and you press the caret button, and then 1 divided by 3, you're going to get negative 1 for an answer. So I get negative 1 times, so that's done. Cube root of 27 we said is 3. That's done. Can't do anything with the cube root of 6, that'll stay in the house. So 6 here divided by 3 gives me m squared. The 9 divided by 3 gives me n cubed. So clean it all up. Negative 1 times 3 is negative 3. M squared n cubed. Cubed root of 6. Take it piece by piece. That's the best way to go about this. Okay? Alright. Now we're going to add and subtract radicals. So in order to add and subtract radicals, we need to have same radicals. So it's like adding fractions. So you need common denominators to add fractions. In order to add and subtract radicals, you need to have common radicals. Okay, so for A, we always got to look for greatest square root. So 32. If I go back up here, 36 is too big, 25 won't go in, then we look at 16. Well, it works. So I get 16 and 2. Alright, and this negative 5 will hang out on the outside. Plus, I'm going to put this in parentheses to kind of show which one I'm working with. We got, not yet. Okay, and then we got 18. The largest square root that goes in 18 is 9, so 9 and 2. Sorry, not happy with the way I'm writing it. Get 9 and 2. Square root, multiplication. 7's on the outside. So it looks like this right now. I'm going to work my way down. So negative 5 times the square root of 16, which is 4, times the square root of 2, plus, we got 9, so 7 times square root of 9, which is 3, square roots of 2. I'm going to drop the parentheses after this step. I'm going to get negative 5 times 4, which is negative 20, square root of 2, plus 21, square roots of 2. So now they're common radicals, so we just add the numbers in front. So negative 20 plus 21 gives me 1 square root of 2. And that's added that one. So moving along. So we have 24, which gives me greatest perfect square goes into it. You got 36 is too big. Then you got 5 is 25, that doesn't go in. And a 4 is 16, that doesn't fit. So it looks like square root of 4 is the biggest one. And you got 4 times 6. Minus 8. And then we got 12. Well, 12 is 4 as well. Times 3. And then we got 54. Perfect squares go into 54. 9. 9 times 6, so plus 7. Square root of 9. Square root of 6. Fitting into that problem. Alright, now you could do like I did last one, do parentheses. And work on each one of these. You get 2 times 2 square root of 6 minus 8 times 2 square root of 3 plus 7 times 3 square root of 6. Clean it up one more. 4 square roots of 6. 2 times 2 is 4. Negative 8 times 2 is negative 16 square roots of 3. 3 times 7 is 21. 21 square roots of 6. Combine like terms. Square roots of 6 are like terms. So 21 plus 4 is 25 square roots of 6 minus 16 square roots of 3. No more like terms, so we are done. Rewrite this one. Right. So break it down. You got negative 3 on the outside times, pull out that negative 1, and then 56. So you got 1, 8, 27, 64. So 56 divided by 27 doesn't work. And then let's go next one down. 56 divided by 8, that should work. It's 8 7. You got cube root of 8 times cube root of 7. And then 189. It's like a 189. So I got 216, 125. So let's try 64. So I'm just looking at these numbers right here, that list. So I'm working on 27 right now. 189 divided by 27 is 7. That works out very nice. Breaks down. Cube root of 27 times cube root of 7. Negative 3 times negative 1. Cube root of negative 1, which we did earlier, is negative 1. Cube root of 8 is 2 times the cube root of 7 plus cube root of 27 is 3. Now I'm going to multiply those together right there. Negative 3 times negative 1 is positive 3 times 2, which is 6 cube roots of 7 plus 3 cube roots of 7. Combine like terms, you get 9 cube root 7.